to the continued section of this boiler section. So we were talking about the boiler mountings, the glass tube water level indicators. Water level indicators generally being used for facilitation in order to detect what is the level of the water within the boiler section. Because if the water level falls below a certain level or the critical level, there may be chances that we are unable to maintain the water level within the boiler section. As a result of entire boiler may be consumed with steam, and this steam can may go abnormal condition of the pressure, as a result of which there may be chances of the explosion of the entire boiler section. So to make out a safety of the concept, a safety concept behind the boiler section, we are also having a glass tube, because whenever the abnormal temperature or the pressure rises within the system of the boiler, there are glass tube has the walls which are ball walls which closes the both the sections, and thereby decreasing thereby facilitating the abnormal working condition within the boiler section, so that we can bring up the normal working conditions within the boiler sections. Mud box, as we know, the water being, even after the purification of the water which is fed into the boiler section, there may be chances that some entrapped particles may be coming along with the pump system as a result, because we know that their pumps are working with the fluids. As a result, corrosion or some other aspects may be entrapped within the pump system, which may be transferred into the boiler section. And frequently after a week or the certain after 6 months or the during the shutdown period, we are going to take out a section called as a mud box, where we are going to remove the sediments of the sediments within the which have been settled within the boiler sections. Mud box is placed at the bottom of this boiler sections. Manhole, whenever the proper working conditions, whenever there is a certain we want to know what is happening within the system of the boiler, there is a glass tube or there is a certain hole is being given for the man to see what is happening within the systems. That is called as a manhole. That safety wall, it basically deals with whenever the steam is abnormally generated within the system, or whenever there is no requirement of the steam within the system, and already we have prepared the steam within the boiler section, we are going to let, or at the before the start of the steam turbine steam boilers, at the start of the boilers, we are going to let the certain quantity of steam which is being inside entrapped within the inside, and until or unless we get the normal working condition within the system, we are going to let that steam to go away into the atmosphere, but without any usage into the system of power plants. So that time we are going to use a steam safety valves, because whenever the abnormal condition is retained within the system of the boiler, we open up this safety valve so that the steam will be released into the atmosphere unless or until we get the pressure within the boiler section normal conditions. Similarly, we have a steam stop valve, which is used for feeding the steam into the section of applications. Wherever the applications we require, we open up this steam stop valve, steam valve, and we let the steam to flow into the system, and wherever the applications are there, at the application site, we manipulate the utilization of this steam generated. Then next, coming to the boiler sections, boiler accessories. Boiler accessories are, these are not compulsory, but for in order to improve the cycle efficiency, as we have discussed, similarly we are not to improve the boiler efficiency, we are going to facilitate this set of components. These components are example economizer, air preheater, steam feed pump, superheater, draught systems. These are the components which makes or which improves the efficiency of the boiler, as well as improves the overall efficiency of the entire Rankine cycles. So when we are going to talk about the economizer is one which basically use the exhaust steam or the exhaust flue gases to heat up the feed water, and this through the economizer we are going to take the temperature of the water to a certain level, and this water will be fed into the boiler sections. In the same way, air preheater, because we know that combustion chamber will be requiring the entire amount of air content for the burning, because we know that combustion is a process of oxidation. Oxygen is very important, as that oxygen is a content present in the air. We oftenly refer, or we oftenly observe the air content into the combustion chamber to facilitate the combustion process. So in that case, air has to be supplied into the combustion chamber for the proper combustion of this, and combustion efficiency improves as soon as there is an enrichment in the oxygen content in the air. So what happens, as soon as we are going to deliver the air with a lower temperature, there may be chances that we are incomplete combustion is a major observation in this case. So what the basic intention of this air preheater is that it heats up the air before entering into the steam power plants or the combustion chamber, so that heated air can manipulate, or heated air can facilitate further in combustion efficiency or combustion improvement efficiencies. Then when we are going to take into account of feed water pump, those pumps which are continuously delivering the water into the section of the boilers. Superheaters, whenever those the power generation power plants are there which are having a high capability of power generation, we need to accommodate a component called the superheater. Superheater are those devices which are capable of generating a very high temperature, as in case of 600 to 700 degrees Celsius in case of steam power plants. This with this steam, the where there is no entrapment or there is no availability of the water content or the moisture content within the water, or the which is the steam so far developed, right, which is a purely dry steam which can be used for turbine expansion. And if you use that superheated steam, there is no problem of corrosion with respect to the turbine sections. So that's why we are going to use the superheaters readily, as well as in the case of boiler sections. Draught systems, there are two types of draught system. Draught is a water column, it is a column like structure, a tapered column where we are going to develop, or the flue gases has to be, after burning in the combustion chamber and after facilitating all the boiler accessories, after passing through all the accessories, it has to be facilitated and it has to be discharged into the environment. So those flue gases, if I am going to discharge at the lower temperature or at a lower locations or altitudes, there may be chances that we may expect the present locality or the local environment may get polluted. That's why it's a facilitating, we are going to discharge these flue gases to a very high elevated altitudes. So to facilitate that, there is a column which is called as a draught system. Draught system, well, two types of draught systems are the natural draught and artificial draught. Natural draught will be working, it's also called as a mechanical draught, whereas artificial draught are two types of there, forced draught and induced draught is there. These draught systems will facilitate this pressure due to the pressure difference. In the case of natural drought, due to the pressure difference between the atmosphere and pressure inside this drought system, we are going to have atmospheric pressure has been lower, as well as the pressure inside coming, the exhaust flue gases which are coming inside and entering into the drought system will be having higher pressure. We know that always there is a flow of the fluids will be possible whenever the pressure difference occurs, and this pressure will be higher inside and pressure will be lower at the atmospheric pressure will be lower when we compare. As a result, flue gases readily deliver into the atmospheric conditions which are at a higher altitudes. So this is called as a, by natural mode we are going to deliver these gases, flue gases released into the environment. That possibility is called as the natural drought systems. Artificial drought systems, where there are certain cases whenever where we know that there is a chances, there is a limitation for any height of the columns. So that's why we have to facilitate that cannot go behind certain height. So there is a restriction or there is a limitation for the drought system columns. So that's why we are going to deliver, they are going to keep up certain devices which facilitate forcible movement or forcible removal of these flue gases from the drought from the plant system and deliver into the environment.